last time? There's a ratio there. Well, that 6 to 2, that 6 to 3, that 2 to 2 is important. All right? If you got that screwed up, then of course the answer is going to be wrong. All right. Now, we are starting with 89.3 grams of this. Okay? Now, which reactant is in excess? The aluminum or the hydrochloric acid? The acid. Why? Because there is no mention of a mass. When there is no mention of a mass, it just says it reacts with it. You assume that it's an excess. Now what that means is you're going to take your hunk of aluminum, and no matter how much acid you need, I'll bring it to you. If we got to go to the stock room, I'll go to the stock room. If we got to go to the store, I'll go to the store. I will get you the acid you need to completely run your reaction. That's what excess means. When there's no mention of the number value in the problem, then you assume that that one's the one in excess. Who's happy? Who's not happy? Oh, he's not happy. All right, what's that? Jethro, right?
Yeah.
All right.
Mass,
No, well, you will, but it comes out in the method later. All right. So, what am I looking for? I'm looking for how much aluminum chloride I produced. Let's give it a go. 89.3 grams of aluminum. I'm going to the periodic table, and I know that 27 grams of aluminum make out 1 mole of aluminum. Now, is there anybody that does not see where the 27 came from? Let's take a look. Do you know where it come from, Brittany? Are you good? How about you? Happy with where the 27 comes from? All right, now looky here at my ratios. My ratio will be 2 moles of aluminum. Jethro just asked me, don't you multiply that number by 2? Yeah. Now, wait a minute. 2 moles of aluminum chloride. You see, why am I putting aluminum chloride on the top? Well, that's the thing I'm looking for. Okay. 35.5 times 3 plus another 27 should give me 133.5 grams of aluminum chloride per 1 mole of aluminum chloride. So what am I going to be left with? My mass of aluminum chloride. $441.5 grams of aluminum chloride. So if you was to run this reaction, you would expect that there would be 441.5 grams of aluminum chloride that you made, just sitting there at the bottom of the flask or in solution. If you were in water, it would be soluble. That's all she wrote.
Where do you get the 133.5?
Oh, where I got the 133.5 aluminum chloride, went to periodic table. There's 1 aluminum, which weighs 27. There's 3 chlorines. Each one of those weighs 35.5 apiece. And that should be 133.5. Do you see that? I mean, really chlorine weighs 35.45. I just rounded. All right. Again, I want to reiterate this. I'm a professor on my feet working without a periodic table. I'm guessing to move the class along. But if you were working me in the research environment, you use every single number in that periodic table. Because guess what? There's a lot of error in science sometimes, and you don't want it to be in a periodic table. All right? You got enough issues working in the lab. But answers are very close. Sandy, did you get it? All right. Well, isn't that Jim Dandy? Should we work another one? Why don't we pick the typewritten one? Throw in a little extra stuff. That sounds good, right? Chapter 9. Here we go. Number 29 out of chapter 9. Here's number 29. It says aluminum reacts with bromine to form this. 2Al plus 3 Br2 yields 2 aluminum bromides. Number 29, page 196. Okay. Now, what type of reaction is this? Combination, she tells me. Remember what a combination is? We didn't talk about it? We just did the 3. All right, here's quickly. A combination reaction is as follows, and you do not have to know how to predict these because sometimes they get very complicated. But here's what a combination reaction is. 2 or more things on the left. On the right, exactly one thing. Okay, the combination. Get it, things combine to make one thing. So here we go. We've got bromine. We've got aluminum. They're sitting there happy. They're going to start beating around like this at a frequency, and pretty soon they're going to hit and make one thing. Do you see how that's a combination? 10 and 4. Now there's another one you say we didn't talk about, and this is all I talk about it normally. This is called a decomposition. And that is when you have exactly one thing on the right and on the left. One thing on the left and on the right 2 or more. A perfect example of this is something like potassium chlorate. If you heat that, you're going to get KCl and oxygen. Do you see how that decomposes? So here's what you've got. You've got a potassium chlorate sitting here, and you start getting it hotter, 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 and it'll fall apart. Decomposing. All right? You do not have to predict those either, because that requires, those are harder to predict, because you have to figure out what's the thermodynamically favorable product. Like, why would this not produce O3? Ozone. There's 3 oxygens over there. Well, the answer is ozone's not thermodynamically favored over oxygen. So let's not worry about predicting those. Okay, so this is a combination reaction on the board over here on the left-hand side. 2 things are coming together to make one. Now, 25 grams of aluminum, 100 grams of bromine. 25 grams of aluminum, 100 grams of bromine. We are looking for how much we could produce in a theoretical world. Now, we got something different happening. There's 2 masses here. Okay? Up until now, we've had a what? How many masses given? Just 1. Okay? Now, a novice student would think that aluminum's the limiting reagent. And then you would ask them why. And they would say, well, that's obvious. Aluminum's in a less amount, so it will obviously run out first. That's not true. Look at these ratios. How much more bromine do you need to aluminum? You know what I mean? All right. So you cannot look and by inspection figure out which one